Okay, boys and girls and Stingray parents, I hope you're having a good day. Today I'm going to introduce least common multiples. Now, least common multiples deals with taking two different numbers, listing their multiples, and then finding the common multiple that is the lowest that they both share. And this is a lot easier to show you than just talk about it. So I'm going to model some for you, we're going to do some together, and you guys are going to be able to master this in no time. Let's start. Hello boys and girls, I'm back. Let's take a look at some different methods of finding our least common multiple. We have the list method, we have the prime factorization method, and we have the Venn diagram method. Now the prime factorization method and the Venn diagram method are very similar, but we're going to start with the list method. And we also need to start by getting our pen red. Okay, let's take a look at the numbers 3 and 5, and also let's just take a time out here with what we're talking about least common multiples. We need to know what a multiple is. A multiple is a product that's found by multiplying two numbers together. So when we say what are the multiples of 3, we're just going to systematically multiply 3 by sequential numbers. And that was a mouthful. Sorry about that. I'll talk English again. So what we're going to do is we're going to take 3 and multiply it by 1, and we'll get 3. Then multiply 3 times 2, which is 6, and then multiply 3 times 3, which will be 9, and then so forth. 3 times 4 is 12, 3 times 5 is 15, and then 3 times 6 is 18. And I need to take a breath here. We'll stop. And then with 5, we're going to do the same thing. List the multiples of 5. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. Wait a second, I'm going to stop right there. What do you see? I see that we have a common multiple. Okay, we have the multiple of 15 is common for both 3 and 5. Okay, and it's also the first common multiple, also known as the least common multiple. So the least common multiple of 3 and 5 is 15. Let's take a look at another method in two numbers. Now the list method is probably the most commonly used, but when our numbers get larger and more complex, you're going to find out that you might want to try some of these other methods. Okay, let's take a look at 12 and 30. Okay, let's prime factorization. Guess what? We have to find the prime factorization of both these numbers. We're going to use the factor tree. 2 times 6 will give me 12. 2 is a prime, 6 is a composite, so I need to keep on factoring. 6 is 2 times 3, and there I have it, all my prime factors, which is 2 times 2 times 3. And 2 times 2 here, I'm going to write as an exponent. So I'm going to combine it right as an exponent. So I have 2 to the second power times 3. 30 is a product of 2 times 15. 2 is a prime, 15 is a composite. 15 is 3 times 5. There's all my primes, and my prime factorization is 2 times 3 times 5. Now when I want to find the least common multiple, what I need to do is I need to write the least common multiple as the product of all of the factors. All the factors. And when I have a common factor of 2, or any common factor, and it's written as an exponent, I have to use the highest exponent. So I'm going to take 2 to the second power. That gets rid of this 2. And then I have a common multiple of 3 with just the exponent of 1. So I just write times 3. And then I have a unique factor over here of 5, and I need to put that in there as well. And there we have it. The least common multiple of 12 and 30 is 2 to the second power, which is 4, times 3, which is 12, times 5, which is 60. So the least common multiple of 12 and 30 is 60. So I know that 12 times 5 is 60. Okay, there's the multiple of 12. And I also know that 30 times 2 will give me 60. There's the multiple of 30. So the least common multiple of 12 and 30 is 60. Now let's take a look at it, a slightly different arrangement. Oops, I'm going to use that information. The first step is we need to, once again, start with our prime factorization of 12 and 30. The prime factorization of 12 is 2 times 2 times 3. And the prime factorization of 30 is 2 times 3 times 5. We need a little more room for my Venn diagram. And let's see how this works. See if I can create a circle here for 12. Like that. Not bad. And hopefully I can create another one for 30. They're not... Oh, that's not good. See what happens when you experiment. Let's get rid of this. Oh, I don't want... Okay, hey, there's a cool idea. Get rid of that. And get rid of that. Oh, I don't want that. I'm sorry about this, guys. Erase all that. And I will just go back to free pen mode, and there we are. Sorry about that. Okay, there's my circle. It's ugly, but it works. Okay, there's my circle for 30. Here's my circle for 12. I need to put all my factors in it. Well, first of all, I have the common factor of 2 for both, so a 2 goes in here. I also have a common factor of 3, so 3 goes in here. Now, if I was trying to find the greatest common factor, it's just the product of the common multiples. But the LCM is a little different. I need all the factors. And I have a unique factor of 12 out here, which is 2, and a unique factor of 30, which is 5. And I need to put them in the Venn diagram as well. And if I want to find the least common multiple, it's equal to the product of all of the factors in the Venn diagram, which would be 2 times 2 times 3 times 5. 2 times 2 is 4, times 3 is 12, times 5 is 60. And there you have it, the Venn diagram method, as well as our other methods. And to be quite honest, I used the list method for the smaller numbers, the prime factorization for larger, more complex numbers. And I prefer using just the, if you can find the prime factors, if you can use the prime factorization method, the Venn diagram is just another way of organizing your data. And some people find it very useful. But I like the list and the prime factorization method. But that's a preference. That's all. Have a great day.